Today, as part of the R programming series and videos, we're going to work on the apply function here. So the goal of this video is just to quickly understand and learn the very, very basics of the apply function. I know I've seen examples when I was just learning to program that were very complex, had a lot of arguments in them, and it was quite confusing. So today we're just going to do a very simple example, and then in the next video, we'll do a more complex practical example applied to a financial example. So let's name this example here in our code, applying functions to matrix rows and columns. And this function just looks like apply. And what it really looks like is it's going to be apply, and then you're going to have m, which is going to be for some matrix. You're going to have dimcode, which is going to be the dimension code. F is going to be the function. And then fargs, which is fargs, which is going to be the function's arguments themselves, which is going to be optional here. And so I'm going to quickly just type them out here so you can see them written out. All right, and let's just create a matrix real quick, and then we're going to pass this into a simple function. So z, we're going to assign to this a matrix. And we're just going to pick out enough here to do a 4x3, so 12 values of any number. And then I'm just going to set this equal to in row is equal to 4, and in call is equal to 3. And we'll run that. And you can see in the top right corner, we have a 4x3 right here. All right, and then for the example here, we're just gonna use the mean function here. So we're just gonna apply this here. And yes, I know. So I'm gonna put this here. I know there is a function called call means. I believe that's what it is. And this function will do the exact same thing, but doing a mean is a really simple function. We're not gonna pass it any arguments. We're just gonna keep this really easy so that we can actually see it, test it, understand it, and then we can kind of build up on that complexity as needed. So we're gonna apply the mean function to the columns. And all we're going to do is just call this call means, and then we're going to assign to it the apply function, and then we're going to pass it our matrix, which is z. And then we're going to go back up here and look real quick. Do we want rows, which is 1, or columns, which is 2? We're going to do columns, so we're going to pass it a 2. And then the function itself is just called mean. Now, this gets more interesting when you can pass it custom functions that you've built through a bunch of stuff, and then you can just iterate through all of the columns and apply it, or all of the rows and apply it across. But we don't even need any fargs here in the end, so I'm not going to put anything. There's just no need to put a comma or a space or anything. All right, and we're going to run that, and then you'll see here, let's just print this out. It's easier to see it in the code output because the font's a little bigger than me viewing the tables. Let's print z real quick. Okay, so these are z. You have 3 columns and 4 rows. If we did the mean of each column, I should get back 3 numbers. And as you can see here, we get back 3 numbers as we took the mean of each column. Okay, so in practice here, I do not like that it outputs these as column values, which you can see up here in the top right. I think it is messy. It's hard to track. I don't know technically which ones go with which columns. And I know this seems really stupid right now, but when you are programming these things out, like I did an analysis recently and for just a grad program doing some simple analysis, I had like 800 and something lines of code, and then keeping tables together and merging and everything. It's really, really confusing. So for proper clarity here, we're going to create a clean version back inside of a matrix. And so I'm just going to nest this all into one equation, because in practice, I would not want to create this and then create a second one to convert it into a matrix. It's messy. It's hard to maintain and track. And then when someone's reading that, they're kind of confused like why you're doing it that way. It's often just best to put it into one clean function, especially as this is not very complex. So it's still easy to read and understand. And so we're just going to call this call means clean. And we're going to assign to this a matrix, and then we're going to assign the apply function z to mean as we did above. And as you know now, this should come out, there's 3 columns and 1 row, so it should come out as in row equals 1 and in call is equal to 3. And if we run that and we print this out real quick, as you'll see here, we now get our nice pretty column headers of 1, 2, 3. Tells us it's just that first row here. And then we have 3 separate values here, which are going to be the means of those. And of course, those match the values up here. Now, you will notice the formatting up here is consistent with 2 decimal places. But since these are separate columns, R is looking at each column and assigning the number of decimals based on that column's values. And so these are consistent, but we do have one with no decimals. That can cause you issues later. That's a whole other video though on how to correct, fix, and maintain that. And so now let's just do the opposite here. Let's just do across the rows. For some reason, your data's formatted a little different. You would like to take the mean of each row and have it at the end here. Let's just create a new matrix here, and we'll just call it row means. And we're going to take our apply function. We're going to pass it z as the matrix. This time, the dim code, so that dimension code is going to be 1. And then we'll put mean back in here. And let's just run this, and we'll print it as well. And run that. So example with rows. And as you can see now, we end up with 4 instead of 3, because if you look back at our original matrix right here, we have 4 rows. And so realistically, these 4 values should be applied to each row. And then again, for formatting and clean coding practices, we're just going to nest these again into something that outputs it as a matrix itself. And so we're going to assign to this row means clean, a matrix, the apply function, z is the matrix itself, 1 is the dimension, mean is the function here. But I'm going to change something here because I do not like the fact that I'm looking at this table and I'm expecting there to be a number on the right side of it, right? There's not. If you now put it into like a 1 row and 4 columns, like my head doesn't quite wrap this around and I have to do some cleaning and it drives me nuts. You can lose track of these sorts of details when programming. And so what we're going to do is I'm just going to tell it inside of here, the number of rows is going to be 4 and the number of columns is going to be equal to 1. And we're going to print this out real quick as well. And so we're going to run this. And now you see we have a nice, pretty in rows format, 1 column. You could technically now append this to the end of the other matrix above the Z matrix. And you'd have a really nice, clean process here. And we could label that 4th column row mean or something like that. So that is how you use the apply function here. Again, it is useful. I'll tell you, for example, like when I ran and worked in SAS for many years, when I was brand new, one of the hardest things to do was we had a big data frame. It was like, I don't know, like 330-ish columns and variables. And then I had a bunch of rows or macroeconomic variables. And one of the things I had to work on is data quality checks. One of the things that you run into with data and economic data from Moody's in this case is they do rebasing of economic data to like 100. And so we had issues in the past where like the data would be going and look like a time series. And then you'd have like a jump like up or down. And then like the series would keep going and you're like, something's wrong with this data. So one of the simple checks, we had a full automated system we built out before, was I wanted just to plot out all the charts so that the economics team, as well as me doing a lot of the data processing and cleaning, could just quickly flip through a bunch of charts and see what they all looked like and make sure everything looked clean and processed. But to do that in SAS, for example, was a bit of a bear. And I believe I ended up pulling in like a SQL function to do it, to iterate through all of the columns, because SAS runs like R in the sense that it is vectorized and it does all vectors. So a good example of this in R would be if I wanted to plot out all these different columns, right? I don't want to write out plot and then specify the X and the Y and then do X, Y1, Y2, Y3, Y4. Like all the X's are the same, but the Y's keep changing the columns. This is a perfect example of how you iterate through that. So if you subscribe to this video, like it, share it, support the channel a little bit here if you're enjoying learning some R. I'm going to do another video next that's coming out right after this one, and we'll do a little bit more of a complex example or two with a little bit of a finance flavor as well, just so you can see how this is actually used in practice and why it's so useful. And again, like I said, iterating through every column if you're trying to apply something is a huge headache. Now you're thinking if it's a mean, like there's already a function built for that, but often I'm wanting to do something a little bit custom, a little bit different, maybe multiple steps and processes all calculated in one. So I'm going to build my own function and then I want to pass that and do every single column on there. So anyways, I hope you guys enjoyed this video. If you did, don't forget to like, share, and subscribe. And as always, until next time.